Hey, what's going on, you all? This is another video on the series of my introduction to the idiot method. This is a method that I've created. I've given an overview in the previous video on just what the entire idiot method is. So this will be the first video where we just dive into one of the initials. So the first initial is going to be investigation. So we just jump over here to the internet. I kind of have all the tabs up for each process, but just kind of want to show you what it would look like for me to just go through the investigation process of a feature. So just a kind of brief overview, an investigation it's honestly a very open process, and this is something that you don't necessarily want to add too much structure to, but just kind of try to think about asking like a lot of key questions. So if I come just back over here, and we just kind of come down here, and actually I'll make a new file. Come over here, I'll make a new file, and we just title it investigation, and I'm gonna shrink. Well, I'll keep it big. So yeah, here we just kind of think about what are some of the questions that we might care about. So in this case, let's just kind of think about an example problem that we might want to solve. So maybe in this case, we're thinking about we want to build some kind of parser. So we're trying to build some kind of we're trying to parse some data and get it into a more usable format. So in one of my other videos, we built a text parser, and so I will kind of use that as an example. That one was very easy to build, but let's just say that you have no idea, you've never built a text parser before, and so you just kind of like have this problem that you're trying to solve. And really the general problem, let's just say the problem was just database. So you're sitting here, you're thinking, hey, I need some kind of database to store my data. So the problem, I need a database to store my data. And we kind of know immediately that we have a user table, and we have I don't know, just like we'll just start there. We just have a user table. So we have some concept of logging into the website. So we need to be able to store this thing into a table on our database. And then our service needs to be able to access it. So if you've never built a service before, you probably don't know anything about all these paradigms. And so the first thing you're going to want to do is just think about, okay, just go to Google and you ask yourself how to store data, for a website maybe, right? And, it's giving you some really good auto fill-ins. And so here we can just kind of start to see, okay, there's this concept of session storage, local storage. We come here, have no idea what this website is, but 5 data storage concepts serious website owners should understand. It's like, okay, big title, web storage, private cloud, public, cookies. And so we're learning about all these different types of storage. If you ask me, this isn't a great article for talking about storage because those are not equivalent at all. But it's kind of tricky to even equate these, kind of put these things in a list like this, because you're kind of talking about completely different technologies. It's like storage. It's like, sure, a cache is a form of storage, but in all intents and purposes, it's not how you're going to think about a problem. Like, you're not going to think about your cache as being storage. You're going to use both. Or really what I should say is that this presents things as kind of like alternatives, when in fact you should have all of them. So I don't like how that one was laid out, but let's just see. So kind of, initially you kind of see all these tutorials talking about storing data on the client and stuff. Then maybe you see this core down here of how to store large user data on a website. And I like Quora a lot as a website. I think you get a lot of actual devs from the industry that come here and answer questions. Oh, and look at this. If you have users registering to use a website, what's the best way to store the data? WordPress is an option. If you're not using a CMS, use a database connection and code required to encrypt. And maybe you're like, what the heck's a database, right? And so you just look that up. What's a database connection? And here you come down here. Database connection allows you to work with database tables. And so you go like, okay, what's a database table? And you walk down this tree until you kind of get to Wikipedia, another really great resource. And then, it tells you, okay, this is a collection of related data held in table format within a database. Click on this, a computing database organized in small databases stored in file systems. And you're like, okay, you read through this thing and you're like, okay, this kind of sounds really similar. I always say kind of the first two sentences are going to tell you everything. Everything after this, like this second sentence, is kind of going to start to tell you implementations, things that are modern concepts, modern design patterns. And then this third one is going to kind of tell you other just like examples of things. And it can be a really useful one to read. So, this first one and this third one are going to be very useful if you're just trying to learn how to like quickly use Wikipedia. And then none of this stuff is ever going to be that useful for you starting out. If you're just learning about a technology, don't waste your time on this. This stuff is for pros. Like, someone might get upset at me saying that, but it's like, no, this is way over your head. If you don't know what a database is, don't even try to read all this stuff. What this does is it fleshes out and makes you, it's very much a pro resource. So once you have kind of a core concept of what a database is and you've implemented it, then you kind of come down here and you start to better inform yourself and flesh out your knowledge. But that is always going to be a process that you do on your own time after you've completed the project. It's not this, none of this data is going to be useful to helping you solve this project right now. Maybe this could provide you a little bit of details, but they've already provided it right up here because NoSQL showed up down there. There's like an iteration table of databases throughout history. And they tell you right here, okay, look, NoSQL is an option. And so like I say, you kind of skim this thing and you see, oh, okay, database, NoSQL. And the reason why I always want you to, when you're investigating, why I want you to go after names of things, go after products, because products are things that you can go test out and make sure that it's exactly what you want. And most products always have demos. So, we go look up NoSQL. And we can kind of see some stuff here. Maybe, okay, cool, there's a YouTube video on this. And so we kind of click through the YouTube video. I'm going to pause it. We click through the YouTube video and we kind of see, okay, cool, this is what this thing is talking about. And maybe this isn't even that useful to us, right? Like, NoSQL is a concept. It's not really an actual database type. But watching this video, all of a sudden, we have a very good understanding of how this database might work and how it might be useful to us. And then lo and behold, right at the very end, it's kind of giving us some resources that we can kind of leverage on to use this. And this starts to fill in our table of things that we can kind of consider as solutions to our problem. So we look at this and we say, okay, cool, there's like a cloud column and there's a self-hosted column. Maybe you have to go look up what that word is, and maybe you have to look up what cloud is. But you can see how you have this model and you have a lot of questions that you are popping up, right? So I need to, so like I say, right now, and really I shouldn't even use this word, but you're just saying, I need to store my data and I have user data that I'm storing. And you might not even know what the schema is going to look for that user data, but all you know from the user data is that you're going to have some username, you're going to have maybe a password, you're going to have maybe a photo URL, and you're going to have, I don't know what else. Like, you're probably not going to know this off the bat, but you probably want to give them an ID. and you'd probably want to give them some. You probably also want to kind of keep in mind on the creation date of the profile, but you probably don't know that when you're starting out. But yeah, so here's the data that you feel like you need to be able to store when you're kind of first building out your problem. And like I say, like, so this is what I've shown you. So you start out here with this question of like, how am I going to store this data? Like, I have no concept of a database. I don't know about parsing things. I don't know about this whole server infrastructure. And so it seems like a huge problem if you've never ever encountered this kind of stuff before. But one of the reasons I've kind of given you this framework of the idiot model is that it helps you take on these huge problems when you have no idea what's going on, and it helps you kind of focus them in and get more targeted towards the result that you're going for. So what, you know, with the quick glancing and research that we've done before, we can kind of understand that, okay, there's probably some kind of a database that we want to use. So it's like we probably want to use some version of a database, right? That's we already have that kind of note. And you know, from reading Wikipedia, we know databases have kind of schemas. Databases have already been implemented. There are different types of storage: client, server. And so here's just the insight in just the first 5-10 minutes. Here's all the insight that we kind of have just quickly glancing through those videos. And, you know, let's just assume that maybe you watched that whole YouTube video. You probably would have a lot of information, right? You might even kind of have an example of what your database would look like. You know, we might also know we store user data as a table in the database. So with these kind of insights, the next thing we have to say is, okay, well, where am I stuck, right? What's the question that I have right now? After kind of doing this research, I figured out that, okay, you know, to store this user data, I need to use something called a database, but there's different types of databases. I don't know what all the trade-offs are. You know, I can tell you that when you first start out looking at databases, it gets really complex. So what I'm going to tell you is, in this phase, we kind of we want to search exactly the thing that we're concerned about. So a key word here is trade-offs, and I've already given it away. And so we want to think when we're coding out a problem. The great thing about this point in the internet is that everybody's probably solved your problem before, and they've already documented it somewhere on the internet, either on Stack Overflow, Wikipedia, Quora, Reddit. Someone has probably already documented it in some kind of form. It might not be in a clean form like a YouTube video or a blog, but someone maybe has already thought about your problem and at least kind of given some opinion on it in a comment section somewhere. So this is always going to be your friend when you know the type of your solution. So this is the problem that we have, and we know that the solution is a database. So we're going to always use this keyword trade-offs, and then we're going to say, you know, of a database, right? So trade-offs of databases. And here I can tell you, don't ever use scholarly articles. They are way over your head. And many of these algorithms and stuff have never been implemented before. They're all theoretical. And try to go to more reliable websites. So here I'll tell you that one of the things is trade-offs to choose a database. So I can tell you that you want to stay away from theory. When we're building out like a real feature, we don't want to spend a whole lot of time kind of focusing on the theory and stuff, because we need practical, right? Like I don't I don't care about learning about the hashing algorithms and the binary trees and red black trees that get implemented in these databases. It's really cool stuff. I can come back to it, but it doesn't help me solve the problem right now, which is what are the databases? What kind of database do I want to use? So here we see Quora, and Quora is like a pretty cool, like I say, very reliable website. And we can kind of see that, okay, well, they're talking more about the trade-offs and maybe of using certain types of databases. And that might not be exactly what we want. And so here, if trade-off isn't working for us, then what we can try to just say is just types of databases. And so here you start to get things, and I won't lie to you, like this is definitely a lot of information to process, but this is all good information for you to process at the beginning. It's going to feel very overwhelming when you have absolutely nothing stored in your databases, in your own personal databases. But as you are able to filter through information a lot more, you're going to be able to quickly jump to the stuff that you really need. Like I say, I can look at this Indeed.com and say that, okay, great. Like this is actually kind of cool. Great. Like this thing is telling me what a database is, and it's telling me all these different types of databases, and it's giving like me a little bit of a blurb of each one. Now I can tell you that you're not going to be able to tell which one is the thing that you're going to want to use, but this is informing your model and helping you think a little bit more. Now I would say this is too much data for most people to process at the very beginning, but what you can do is you can come back to that. You just put a new tab for that and come back to that and say, okay, well, I found this resource. I'm going to go look for something a little simpler, but I'm going to come back to this when I have a little bit more data and a little more understanding, and I can process that kind of a database. I mean, I would say like this is once again, this is like a medium tier kind of article. Like this is for someone that is experienced with databases to some degree, and maybe has used 2 or 3 of these, but not all of them, right? So it's something, and to get that kind of sense, like I say, just takes time. You almost have to be advanced, which I would say I'm probably is just near medium to advanced, where I can look at this and go like, oh, okay, that's not useful to me, but it's very interesting, but it's not useful. Geeks for Geek is another really, really good website. This is actually a good point too, is think about who the website is catering for. Geeks for Geeks is catering towards the noob that knows absolutely nothing about code, is probably taking college courses, and look at that, right? Even has a university as an example. So this is going to be a great place to try to find examples of databases. So here you can kind of just see that, okay, it's describing things just like the Indeed.com is, but it's going into a lot more detail. It's giving you a lot more diagrams. And you might, as you're reading an article like this, you might start to say, well, I'm actually being drawn to this NoSQL thing, or I'm being drawn to this relational database thing. And it's a bit early for you to be kind of saying, okay, I'm going to make the trade-off, right? The benefit of relational databases is speed, but I don't like the strong binding that it requires with keys. You're not gonna be far enough along to have that kind of language. But what you can, and what will start to happen, is that internally you'll start to find things that you really like. So you'll start to look at something like a NoSQL database, or maybe an object-oriented database, and you'll start to say, well, I actually really, really like this concept because, I can really understand it easily. And so we'll say, well, let's just go look up an example of it. Let's just go look up an example of this and see if we can play with it. And this is an invaluable skill, especially in the investigation phase, is just to start playing with stuff as fast as possible. So if you start playing with, and look at this, right? So as we start thinking about playing with it, we start to hunt for a demo. And we're like, okay, can I find a video of someone setting this up? And can I find some instructions on how to set this up for myself really quickly? And what this is going to start to help you do is people are going to start to voice their opinions about things instantly. The internet loves to voice its opinion about stuff. So sometimes it's better to just be quick and just find some solution as fast as you can. And then the internet will naturally let you know if it's angry about it or if it really likes it. So lo and behold, as you're getting an introduction to NoSQL, boom, here you have the advantages and the disadvantages of it. And so now you can start to say, well, does NoSQL work for me? And not only that, but if I know that Geeks for Geeks made this kind of a layout for NoSQL, then maybe I can go through each one of these and see if it has that same layoff, right? Does it have the same trade-off section within its code? So, or within the write-up. And so you can see that if we kind of come back over here, we started by hunting for trade-offs in the database. And so what we quickly found out was we got a better idea of all the types of databases, and types of databases ended up being what we ended up typing. Oops. So we ended up finding out about more types of databases, learned a few advantages. Well, I'll just say trade-offs. And then the next thing to do from here is, can we find some demos? Now, why I like demos is because you don't have to do any work. You can watch someone else set up, and you know that they succeeded, right? Because a lot of times when you're looking at demo code, it's expired. A lot of these demos don't even work a year after the tutorial has been published. So you can save yourself a lot of time and headache setting up your environment, all that shit, and you just watch someone's demo of something. And you can tell from the demo, is this something that I want to invest in? Does this look like something I can really use? Does it solve my problem? And I'll write all that stuff down, right? Saves setting up environment. Like I say, this is very expensive. You don't know what kind of software you might be needing. The tutorial usually doesn't tell you all the dependencies that are required on it. And like I say, it's just there's a lot of bugs that happen in people's demos that you end up having to spend time. And in this case, once again, think about this investigation is costing the company money, or if this is your personal project, it's costing you time. So you don't want to just be spending your time figuring out, well, why is this Visual Studio project not building when they told me that it was going to build? So save yourself some time. Can we just find some demos? And then we're going to ask, does it look easy to use? Is it well supported? Is it open source? How long has it been around? Can we use open source? How long to integrate? Costs, right? So here you can see that we're kind of getting in the more specific phase of our investigation. So we've kind of locked eyes on NoSQL, and now we're just kind of diving into NoSQL. And so for the more vigilant among us, we might look at this and say, well, we're diving into NoSQL too quickly. There's a lot of different options. Shouldn't I kind of consider all those options? I would say no. That's because right now you don't have a model of anything. So you don't know how to do a trade-off analysis of NoSQL versus a relational database or an object-oriented database, because you don't know what those concepts are. You don't know what examples are of them. So you have to go look at the examples. So in our cases, we've seen that there's 8 different types of databases. And so to do a full investigation, I would have to go look at examples of all 8 of those databases. And so that's kind of how you have to think about this problem is if I am new to databases and there are no restrictions on what database I can use. And that's a great question. Are there restrictions on what database I can use? So yeah, if there are no restrictions on our databases, then we need to gain information about every single type of database. And the best way to gain information is, like I say, watching a demo. Watch a demo, see an example of each one implemented, and gather answers to all these questions. Now, as you get really good, you're not going to really answer all these questions explicitly on a sheet of paper. Though it can be good. I like to include answers to these questions in all my design docs. So I'm actually going to say you should include, if you are going to make a design doc, you should definitely include these as answers somewhere in your design doc. But as you get more comfortable and you're moving faster, you're going to kind of keep these questions in your head already, and you're going to already have an idea of what to use. So, in many people's cases, if they say that I want to use a relational database because this is a speed heavy operation and, I have very strong non-changing table schemas for my data, then it's like, okay, I'm going to use SQL, right? MySQL, and I'm going to be done with it. I'm not really, and some people are going to say, okay, I'm going to use Postgres for this. And some people are going to say, I'm going to use NoSQL or SQLite and Python for this. And, because they've already worked out some of the equations and trade-offs in their head. And that's okay, right? A lot of times it's how long to integrate is the most important question. I'll tell you, when you're first starting out on a project, if there's a solution that's going to take 3 days instead of 3 months, everybody's going to choose the 3-day solution. And then they're going to say, well, we'll come back and implement the 3-month solution later. So these are all kind of like very common questions that you'll need to consider. So these are not just questions for this investigation. These are questions that you need to ask in every investigation. And if I think of any more questions, I'll kind of add them maybe in the description. But yeah, these are all things that you should be asking yourself as you're walking through an investigation to make sure that you are kind of covering all your bases when you're choosing a technology. And so, like I say, when we looked up the trade-offs of our databases and we switched over to using the tactic of types of databases, then we saw there were 8 different types. And so now we've got to watch 8 different demos of all these databases, and then make a decision, hopefully from that. Now I want to kind of talk about, so, when I say that we make a decision off of 8 demos, that's kind of a situation where you don't have anyone else helping you. So, in some company environments, you don't have people, even your team. You can't rely on them to give you an answer to your question, to the question. You are the one that has to come up with an answer and a solution after that. So in those kind of cases, the research burden is extremely heavy. And that's why why investigation tends to be the most hated part of the dev process, more hated than testing, because it is rigorous, right? It is research, and it's very academic almost. So for people that didn't like school and like to kind of focus on doing, this can be kind of a painful eating your vegetables, and it's expensive, right? It costs a lot of energy to do all this reading, to watch all those videos, to look at demos, and in some cases you have to do the demos yourself because there might not be videos of it just yet. Likely, if there's no videos of it, you shouldn't be using it. It's probably too cutting edge, but yeah, like it's and actually I'm gonna do a video, probably a follow-up video, optional, that just kind of talks about each of these kind of questions in an investigation, because I think that would actually be a good blurb. But yeah, if you're doing this all by yourself, it can feel really, really overwhelming. But just note that investigations aren't necessarily supposed to take just a couple of hours. In my case, because I have so many things in my head already, I can answer a lot of these questions pretty quickly. But in your case, you are building the model all the way out. In your case, if you aren't as experienced as me, or maybe you're more experienced than me, right? But if you don't have a lot of experience yet, then you're still building out that model, and you want to move very slowly through this phase. So an investigation like this might take you 2 weeks to even a month to try to figure out. And sometimes you're going to have to just make the decision that I'm just going to go with the solution because I don't have time to look at every possible solution for this. I don't have time to optimize on what the best option is in this case. But yeah, this is, I will say that investigations are things that will go down as you get older in your career as deving. They tend to, the time to investigate tends to trend down, but initially the time to investigate is a very, very expensive process. And yeah, it just takes a lot of time to get through it. So yeah, I'm going to quickly wrap up on this. And then, like I say, I'll do a follow-up video just talking about these questions and kind of if someone came to me with answers to these questions, kind of what I would kind of expect them to have for me. And one thing I will say that, so I was talking about if you were working on this by yourself, it can actually be very expensive and take a long time to investigate. Whereas if you're working with people, and this is why it's very good to work on projects with people, especially people that are better than you. In fact, try to, realistically in college and in your job, make sure you're working with people that are better than you and you're asking them these kinds of questions. So not necessarily having them do the work for you, but when you go and do your investigation and you find, hey, there's 8 different types of databases, and you go take that to a coworker and you say, hey, what do you think would be the best kind of database to use? And then you can kind of have this discussion and you all can talk through each of these answers without you having to necessarily jump through all of them. Now, some coworkers will say, hey, you need to kind of go get answers to all these questions for all 8 databases and then come back to them. And then you all can kind of discuss it. But sometimes you can use your coworkers to shortcut answers to all of this. So like I say, if you have said that, hey, there's 8 different types of databases and I'm looking to store username, password, and photo URL. If you came to me and asked me, hey, do you have a good idea of a database I should look into for storing that kind of data, I probably would tell you to use NoSQL. And I would ask you, like, what stage is your project in? Is it going to get big? What is this eventually going to be used for? Is this production? All right. And I'll start asking you those kinds of questions, which you'll probably already have the answers to. And then we can pretty much get to a conclusion there, or at least 80% of the way there. And if we don't get to a conclusion, you might resolve at, you might get a little more up the road on some of these things, and you can go research them later to come up with a final conclusion that you can bring to the team in the design meeting. So anyway, like I say, I'll discuss these questions in a follow-up video, but let's talk about now what happens after we have answers to this. So, we've gotten answers to all these questions for 8 DBs. And so now you're feeling pretty good, right? So after this stage, like I say, it could take a couple of days for some people. It could take a couple of weeks. Don't beat yourself up. But you've gotten answers to all these questions. So now what? So now you just kind of need to decide, right? So, and this is honestly pretty easy. Like once you've done all of this kind of research, it usually pops out. You either get 1 or 2 answers to this, and you don't even have to make the decision on that. Now you can take that to the team, but it's usually going to come down to speed, price, and storage. Those are usually the variables that we will talk about, and speed is an interesting one. So it's not only is it the operational speed of the database, or just how fast requests kind of come back from the database and how fast it is to store stuff inside of it, but also just the speed to implement. How long is it going to take to integrate with this database? How much work is it to maintain this database? So all those things are kind of questions that you are gonna need to ask to maintain. And the same thing goes with storage, and storage is mostly a component of price. We don't really care about storage ourselves personally, but in terms of the price, we might say that we don't have the money to just have something. We can't necessarily afford a terabyte cluster of in one different type of database. So that's one thing to kind of consider. So you've gotten your answers, and so once you have all your answers, you kind of have to take my word that you'll probably you'll have them all laid out, and you'll look at them and you'll say, hey, I actually think I'm going to go with 2. Now, if obvious, we narrow down to 2 or 3 options. If not obvious, we'll present all to the team in design phase. So with the design phase is where we really we expect to get input from other people. When you're new, just starting out, you will not be able to do a design phase by yourself. I just don't expect that, because you inherently need to learn how other people are thinking about the problem, and how they think through the problem. So that's an empathy that you don't gain just by thinking about it by yourself, because you only have you thinking about the problem, and maybe the people on the internet and how they think about the problem. But when you have these in-person conversations or just these virtual conversations with people on the same problem, you can hear how they went about solving it and some of the trade-offs and considerations that you need to be making when you're looking at the problem. So with design meetings, as we're prepping for them, we don't necessarily want to sit here and talk about 8 different databases the entire time. Like, a design meeting might only be 30 minutes. And so you can take the entire meeting talking about the trade-offs and the cool factors of 8 different databases. So that's why it's really important for you to try to narrow it down to 2 to 3 options. And then even thinking about narrowing down to 2 to 3 options, that allows you to design a lot more specific. And I'll show you what design starts to kind of look like in the video I do on design. But when you come into a design meeting, you kind of want to have an idea of what your implementation looks like already. So you can't have a good idea of what that looks like if you have 2 to 3 different, if you have 8 different options that you're going to be pulling from. So the only way to really be able to be specific in a design meeting and get really good feedback is if you already know answers to a lot of core questions. So like I say, try to narrow it down to 2 to 3 options. If you are personally having trouble narrowing it down to just 2 to 3 before a design meeting, go talk to someone else and get their input before you go to present it to some other people before that design meeting, because it just probably means that you don't have a good understanding of the problem. Maybe there's questions that you still need to ask about the problem to help you narrow it down a little bit more. Like I say, these are really good questions to ask on just about any project during the investigation phase. And you probably already have answers to a lot of them before you even begin. So it can be a great way to help you narrow down what all your options are. And like I say, you should pop out with 2 to 3 in most cases. But yeah. So like I say, we'll deep dive into these questions in this next video. Let me see, is that everything? So I'll just kind of end it with, once you've gotten your 2 to 3 options, we can kind of consider the investigation phase closed. So we're leaving the investigation phase with so we have a decent idea how to implement. So not everything has been ironed out, but we know that, okay, if I have 2 options, maybe I'm going to choose NoSQL, maybe I'm going to use SQL. So between those 2 options, we kind of have an idea of what it would look like to implement those 2, and we can demo them. So we've watched a demo. We maybe have not even coded in the demo, but we've watched a demo, so we have an idea of what their schemas look like and what it looks like to integrate into those libraries. So like I say, you should be at least able to read code if you're watching these videos. And so we can recode and we can copy and paste blurbs out of the videos to say, hey, this is kind of what I expect my user class to look like when implemented in NoSQL. Here's what I think it'll look like implemented in SQL. And then we can talk about that in the design meeting, because the design meeting is going to be where you actually sketch out and schematize everything. But the investigation, we're just trying to see, we're really just trying to see, is the problem solvable? How long is it going to take to solve this problem? And then, maybe, and depending on just how, how scant resources are or how high your privileges are, you might be really considering things like cost and all that stuff. And you might have to really present the story and petition for this story. So, but yeah, like I said, I think this is the main point, honestly, is we have a decent idea how to implement things. So we're not scared. We know the language that we're going to be coding in. We know the framework. We know kind of the names of the database types. And now we're just kind of good to go, right? We have a good idea of the tactic and strategy that we're going to take when we implement the story. So we're not starting off at square one where we had no idea what a database was, but we're leaving with the idea that, okay, I do want to use a database, and I know that I want to use either like a NoSQL or a SQL database, and now I'm just moving forward to figuring out how to use them instead of what I should be using. So maybe that's what this really solves, is the what, in terms of kind of when you're doing an investigation. I mean, honestly, you should solve the who, what, when, where, and how, but I think this really focuses a lot on the what, on just like, what are we going to be using to do this kind of technology? But yeah, we might not necessarily know how long it's going to take to do it just from this investigation. We might have an idea, but it really comes out in the design phase of just how much time it's going to take to implement this stuff. So anyway, that's going to be it for this video. I will do a follow-up video going through these questions and common answers that you should have for them. But yeah, other than that, I will see you over there. Bye.